Hello guys, I have an interesting application Rizz Chat which is similar to WhatsApp. In this video, I would explain the data structures which I have used and the C code in the further video. So yeah, these are the features which I have added in my Rizz Chat. The first is text messaging and the sending, compressed text message, searching, faster searching approach, recent chat list, recommendation, chat history, profile, and notification. Let me explain you the feature by feature elaborately. So yeah, first is the text messaging and the and text messaging and sending. So here where users will be able to enter the text messages and sending them to their contacts. As you know, this is the basic feature which we come across in an WhatsApp or which we use in your mobile. So here with the data structure which I have used is queue using array. The message which come first will be delivered first. The time complexity is big O of n. Big O of n is the O is the order, and order of the n is the number of arrays. Here, the time complexity depicts the total the time taken to run a code here. And now let me explain you clearly about the queue using array. So yeah, here in queue using array, there are four main concepts. First is enqueue, dequeue, display, and delete. The first enqueue is nothing but the deleting of enqueue is the adding of elements to the arrays, and dequeue is the deleting of the arrays, and display is the displaying, and delete is the deleting of an array from n. So to implement queue using an array, first we have to create an array of size n and taking two variables front and n, initializing it to 0. And rear index is up to which the elements are stored in the array, and front is the index of the first element of the array. Some of the implementations like queue operations are enqueue, dequeue, front, and display. As I mentioned before, enqueue is for addition, dequeue is for deleting. So the first, when we implementing queue using an array, for deleting an array, adding an array, first we have to check if the real element is less than n. N represents the number of arrays. Then it means the array is not full. Then we can add. If the array is equal, if n is equal to if real is less than 0, we can delete an element. If we can delete an element and displays the print all the elements of the queue. So next feature is compressing the text messages. Here, as you know, when we send a large amount of messages or content, it takes time for loading and for sending. So in order to improve the speed and the app performance, we use the compressed text messages, where we compress the messages and send them, which improves the performance of the app and reduce the traffic. So here I have used the data greedy approach of Huffman coding. Huffman coding is a greedy approach. Let me explain you the Huffman coding detail. Here, in case if this is the message which I am sending, first the character is the character whichever I am sending. Count and frequency is the total number of occurrence of the character, and code is the binary code. First, let me write the characters. First is A, B, C, D, and E. First, let me count the count and frequency and nothing but the number of times the A occurred in the message. A occurred thrice. and B is 5 times, and C is 6 times, and D is 1, 2, 3, 4 times, and E is 2 times. So the total number of characters are 20. So now I have to arrange these count and frequency in small, from smaller to bigger. So first let me write it is 2, 3, 4, 5, and 6. And now I have to add the smaller numbers. First let me in this 2 and 3. I have to take two smaller numbers to add. So first let me take 2 and 3. If I add, I get 5. And next the two smaller numbers. I can take 4 and 5. So I would get as 9. And next two small numbers, which is 5 and 6. Let me add that both. I get 11. So when I add these both, I get 20. You can also cross check here the total number of characters. So it's 20 20. So it is equal. So after that, I have to assign 0 and 1. 0 to the left hand side of the node, right, and 1 to the right hand side. So left side I have to assign 0, 0, and 0, and 1 to the right hand side. Here it is, 0 and 1. And now I have to check for 3. What is the binary code? Now 3. Let me start from here. 0, 0, and 1. So it is 0, 0, and 1. Now it's for 5. It's 1 and 0. The same thing you have to do for 6, 4, and 2. The same, now let me do for 6. It is 1 and 1. Now it's for 4. 0 and 1. Now it's for 2. 0, 0, 0, 0, it's 3 zeros. So yeah, by this we can compress the text. The same thing is for decoding it's also same. If I give B here, for B how much it's 5. So I can write as 1 0. It's 100. No, I'm sorry. No, it's for B. It's 001. You can encode the same. Okay, and now for encoding, now I can check. Now I have got here 5. It's 5. Now let me take B. It's 5. So 1 and 0. So you can write the same thing as 1 and 0. You can decode the same. So next feature is, let me change. So searching. The here user will be able to search for the particular person and view his profile or chat or his chat history. Now, yeah, as you see in WhatsApp, as now you see in WhatsApp, you'll be having a search column. When you type a number or name, you'll be able to get inside the chat and see to their chat history and your chat history and the media whichever you share with them. So here I have used hashing in array for quick searching. So its time complexity big O of 1. So at a time, as you can search at a time only one element in the search box. So its time complexity is big O of 1. Yeah, now let me in the list 11, 12, 13, and 14. Now we can assign number as 1, 2, 3, 4, and 5. Now here 11 hash of 10. It's not 10 here. It the 10 represents the total number of arrays. Total number of arrays. Now if in case now it's 4. 11 percentage hash of 4. So the 11 goes to 1. The same thing vice versa. The 12, 3, 4, 5. It goes to the same. So this is the hashing. And next feature is uh, faster searching approach. Here we will make the searching faster using dynamic programming by finding the common subsequences. Here now let me explain you with an example. In case now you have to type now in case now you have to search for a name Aditya. Now in contacts you have searched, you have saved as J Aditya. Now when you type Aditya, you will be getting an J Aditya also, as the majority of the name ADITHY as ADITHYA is present, that is Aditya. So you will be able to get in your search soon. Let me explain you. See now this is my this is the word which I have to search. This is the word which I have to need. This is the word which I need. Now, if I type this, I have GAGGTAB. Now here the common, whichever the common here in this both string G is common, T is common, A is common, B is common. So I will able to. So this is these are the four longest common subsequence we'll be getting in this feature. So by this method we'll be able to enhance our searching approach. So here the time complexity is big O of m and m into n. M represents the vertices and n represents the vertex. Sorry, n big O. So here the time complexity big O of m into n. M represents the vertices and n represents the edges. So next feature is uh, recent chat list. As you know, whenever you open a WhatsApp or something, you will be able to view, instead of viewing the whole every contact, you will be able to be viewing the recent chat list, so that which helps us to search and type easily. So here the scrollable area showing recent chat person names and profile pictures. Clicking on a contact loads the chat history with that person. So whenever I need to search someone's name, I used go to recent chat and I used to scroll. So for the scrolling, I use double linked list. So here the time complexity are in two cases, it varies. Big of one for moving the person who sent the message at the beginning of the double linked list, for and one more is for displaying all the persons in the chat list as big as in, if in case if you have to see any one single person's chat in the recent, so you will have a big O of one. In case you have to view everyone's chat, we use big O of n. There n represents the total number of chat list. So let me explain you the double linked list. So here we will be in normal linked list will be having data and the address of the next node. Address of the next node. Here we'll be having a value. Here we'll be having a value. In case in here I will have, in case I have one here and its address is 100 and this one address is 200, 200, 300, and here it's 400. Here 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 as it is a head value, here is always it's a null. So here I would have this address of the next node, it's 200, and here I would be having the address of the previous node, that is 100, and here the same vice versa. Here I will be having address of the next node, it's 300, and here is the address of the previous node, it's 200. So here I would be having address of 400. The same here, I would be having address of the three previous node, 300. So by this, whenever I go and click a chat, I would be whenever I'll go and scroll, I will be using double linked list. So I would be getting the address of the next node. I'll be able to view the next chat, the same which is used in the Rizz chat. So next feature is we will be using here recommendation. We will be able to find the shortest connection between two users who have actually registered for the app, and the person will be notified as a recommendation of the most common. In case if me and you, if me and one more user is having a connection, I would be getting a recommendation of my friends lists also, so that by this we can increase the connections among the people. So here I have used Dijkstra algorithm. Its time complexity bigger of v square. So let me explain you what is the Dijkstra algorithm. So here first I would select as one node as in starting node. Starting node is this, and I would check wherever the first node is connected. It is connected to one, it's two and three, and I would assign remaining values as infinity, as it is not connected. So I would assign it as an infinity. So first I would take one, and I would select the shortest path in this. I would select the two. So I would go here and it's 2, and next I would check the 2 whichever it is connected and select the shortest path. It's 1. I would go here. So here its value is 4, right? I have to check. Now I have to add this both. 2 plus 1, it is 3. Now if 3 is if it's 3, if as 3 is smaller than 4, I can cancel the 4 and I can change it to as 3. The same thing you have to follow for everything. And now here, let me do here. Now 3 plus 3 is 6. As 6 is less than infinity, I can cancel the infinity and 6 here. The same. And now let me come here. And now here it's 2 and 7. 7 plus 2 is 9. So I can cancel is infinity and add as 9. Now here, from here I'm going to the top. Now I'm selecting the shortest path. It's 2. So I'm going here. So 2. Now 6 plus 2 is 8. Now as 8 is smaller than 9, I can cancel the 9 and change it to as 8. And now I'm coming back here. Now I'm coming now I'm coming back here. It is 5. So the distance of from 5 to 6 is 5. So 6 plus 5 is 11. So I can cancel the infinity and add 11. And now here, the distance from 4 to 6 is 1. So 8 plus 1 is 9. As 9 is less than 11, I can cancel 11 and cancel it as 9. So I have to repeat the same cycle as how many number of nodes are there. I have to do the cycle, that number of cycles. So yeah, this is the feature for recommendation. And now let me switch to the next feature. It's chat history. We use displaying a scrollable area containing the chat history with a specific person. Now, in case if I have to search for a name called name Aditya, now if I go and search and I get the chat history of that specific person. So here, and we will be able to scroll, where we'll be able to scroll and see the chat history. So now here in data structure, what data structure I have used is double linked list. As because there is as you know, in double linked list there is no size limitation as in array. So once the user actually access the data from Firebase, we will store it as a cache, so that it is easily available again until he clears the cache. So yeah, as double links has no size limitation, it is easy for us to access, and it is stored in an and it is stored in a cache memory, and it will be available until when I clear the cache. So its time compliance big O of n, and time for accessing for accessing all chats, as the it n depends upon the how many number of chats you can access. So here, as I use double linked list, as I explained previously as double linked list. Here we'll get the data, and here I have the address of the next node, the same as I have here null as because I don't have previously it's an head value, so I don't have the address. Here I will have the address of the previous node, and here address of the next node. The same thing is implemented here also. So next feature, profile. Here, users will be able to view and edit their profile details, including name, profile picture, and status. As in WhatsApp, you can customize your details, including profile picture, status. Uh, as same feature is also included in the Rizz Chat also. Here, data structure is phone number or name using as hashing in array and struct to store details having various data types. Here, as you know, a phone number and name we have used hashing in array. Here we have used hashing in array and structure to store the details having the various data types. As I explained it before, hashing in array, the same concept is also used here. So the time complex is big often as the at a time as at the time you can ask you can access or you can change or update only one at a time. So next feature is notification. The user will receive the notification for every new message he receives from any person or any app notification. Here, the user will be able to get the notification of the messages or the chats, whatever he gets from his devices. So here, the data structure which I have used is stack in linked list and keeping the heads of all linked list in arrays, as we want the newest message from a specific user to come first as notification to user, and the older ones will be counted. So yeah, here I have used stack and linked list. Let me explain you the stack and linked list in detail. So here, to implement a stack using as linked list, all the linked list operations should be performed based on the operation of LIFO. As LIFO is last in, first out, we follow LIFO in the stack in a linked list. Here will help us. We are in case we have to we in case we are going to implement a stack using a linked list. Here are the certain operations which are using push, pop, peek, and display. Push is for inserting a value, pop is for removing a value, and peek is for displaying, and next, the stack implementing involves node class representing a node in the linked list and stack class utilizing the node class to implement the stack. Pushing an item into a stack is the creating when you're popping an item from stack involves removing the first node from the linked list and returning the data stored in the original head. Yeah, that's all. That's all. My the features are over. Let me show you the coding part. First, we have a chart history. Here we have structures defined having a three components. Data is to store the string data, and two pointers, previous and next, previous and the next. And now, and data, a global head variable is declared, pointing to the start of the list, and uh, add to end is a function that adds a note with the given data at the end of the lists. And now here void deleted position int of position. Here it creates a new node with it's a delete at position is a function that removes a node at a given position. Checks if the list is empty. It prints an it prints the failure message and returns. Otherwise, it transfers the list until it reaches the node. The given position, removing it by adjusting the next and previous pointers of the adjacent nodes. Here next we have the display function. Here, display function prints the content of the list starting from the head. Whichever we have used here, it displays. And next in main function, we provide a menu to the user to add the end and to add the end and the to add the end and the delete portion. Here we use the end and the delete portion to make user to add the end and the delete position and display the list or exit the program. Program manager double linked list, allowing users to add nodes with strings to the list. To the list, delete nodes from the specific positions or display the positions. So yeah, these are the cases where first we ask the user to enter the string to add at the end and and to enter the position to delete and to display. In case if we incorrect, it exists and prints. So yeah, finally we have given the return function. And now let me run this code for you. So this is the double linked list menu. Here we have to write our choice. In case I have to add at the end. I'm giving a choice of one. I have to give a string. Yeah, and it have a, in now I have to display. I'll give 3, and this is the and here it displays. So this is the execution of chat history, and here now we have given us here now here the struct node here struct structure struct node is defined using the struct keyword, and phone number of an array of 15 and character name, and struct node previous and struct node next is defined. Previous pointer to the previous node to the linked list. The create node function is defined, which takes a phone number and a name as parameters and returns the newly created node. Using malloc, where malloc function is used to define the specific amount of sizes or memories to be assigned. And now here comes the insert end function. Here is defined to insert a new node at the end of the linked list. It takes the address of the head node and phone number and a name as a parameters. Inside the function, a new node is created using a create node function. If the linked list if it is empty and it is given as null, here can see it is given as null, or else otherwise the function iterates through the linked list until it reaches the last node and appends the new node to the end. And next we have defined the move node function. Check it is defined to move a node from one position to another position. It takes the address of the head node, the position to move from, and to the position where it has to go for its destination. Finally, the codes are swapped by adjusting the next pointers to of the previous nodes and next pointer to the nodes to be swapped. And printless function is defined to print the phone numbers and names of all the nodes in linked list. It takes the head node as parameters and iterates through the linked list, printing the information of each node. In the main function, here we define the main function. The head node is initialized as null, and the number of nodes is n is obtained from the user. A for loop is also used to iterate n times and prompt the user to enter the phone number and names for the each node. The insert end function is called to insert each node at the end of the linked list. After all nodes are inserted, the printless function is called to insert each node at the end of the linked list. Display the initial contents of the linked list. The, then the users are prompted to enter the position to move from and the position to move to and perform the appropriate arguments to perform the node movement. Finally, the updated contents of the linked list are printed using the print list function. So let me show you the execution of the recent chat list. I have to enter the number of rows. Let me enter two nodes. I'll enter the phone number and name. And as I enter two nodes, I have to give the another phone number and I have to give the name. And yeah, I have to give the position to move from. Now I have to, as I stored in 0, I have to move to 3. So yeah, the process is finished. And next I will next the co- and next now the now now we have taken a maximum hash table size as 100. We are defining hash table size as 100, and we are taking a multiple data types in one structure to store the user data precisely. Here we have phone number, name, and age. Phone number, age, and next we define the structure called user info. User info to store the information about the users. It includes fields for phone numbers, name, and age. The hash function is defined to calculate the hash value for given phone number. It iterates our characters in the phone number. In the main function, an array user infrastructure called user database is created with the size equal to hash table size. All the phone numbers in the user database initially set to an empty string. Then here the user is asked to enter the number of users, and this value is stored in the variable num users. Then the loop is used to iterate through all the users. Inside the loop, the user is prompted to enter the detail for each user's name, age, and number. The details are stored in the corresponding fields of the user infrastructure. After taking the user's information, then copy to the user database using calculator hash index. Number user is asked to enter the phone number to search the user's detail using scanf function. And again, the search index is used to check if phone number is used to check if the phone number of that index matches the user phone number. If it does, the user's details are displayed. And finally, the program ends by giving ends and returns 0. So this code allows users to simple hash table. This demo how to use a simple hash table that can be implemented to store search for user information using phone number as key. And next function is text messaging. And now let me explain for the text messaging code. Here, a queue is and here defining two node and queue. The node structure represents the single node in the linked list and contains the characters of character array called data. Here we have defined the data to store the string value. The queue structure represents the queue. Represents the queue structure represents the queue. and contains the pointers to the front and the rear. Then code defines several functions like create queue. The function creates an empty queue by dynamically allocating memory for the queue structure and initializing the front and rear pointer as null. Is empty. This function checks if the queue is empty by checking if the rear of the queue is null. It allocates memory for the It allocates the memory for the data array and links it appropriately the previous rear node. And here we dequeue. This function removes the node from the front of the queue and prints its data. It updates the front pointer and frees the memory of the removed node. If the queue is empty, it displays, or else it gives an error message. Here again we use the remove all function. This function dequeues all the nodes in the queue until it becomes empty. It repeatedly calls the dequeue function. And here comes the main function. Here in main function we use this main where the user interacts with the queue. It displays a menu of options to the user such as enqueuing a string, dequeuing and removing all elements. And here we take the user inputs to do, and it reads the user choice and perform the corresponding operation. This code provides a basic implementation of queue using linked list and allowing the users to add and remove elements from the queue. So, this was my chat application which I have created using various data structures. I hope you get to know the different data structures and implementation. Thank you.